In this video, we're going to study some parabolas in vertex form. Vertex form is where f of x equals a times x minus h all squared plus k. That's where h comma k is the vertex. The domain for these parabolas is all real numbers, negative infinity to positive infinity. If a is positive, the shape of the graph is going to be a U. So we're going to have a minimum of k, our vertex, but our range is going to go up to infinity. If a is less than 0, we're going to be flipped upside down, which means we are going to start from negative infinity and go all the way up to our maximum k in the y value. So we're going to look at some of these functions without a picture and be able to find their vertex, their max/min value, which just means the y value, and the axis of symmetry. So we're going to continue following these general rules and look at some specific functions. So first of all, it's always x minus h. So in this case, the number we're subtracting is 2. That's the x value of our vertex. And then k is the y value, which is the number we add at the end. So we have 2, 5. So we want to look at the value for a here. We have a positive value for a, so it's going to be a u. Our vertex is going to be a min then, and our min value is 5. The axis of symmetry is always x equals the x value of the vertex. So in this case, it's x equals 2. If we look at our next function, the number we subtract from x is our h. So keep in mind, this is really -7, and the number we're subtracting is -3 in order to get x plus 3. So the number you subtract from x is the x value of your vertex. So in this case, it's -3. And then the number at the outside is your k. Right? You have the number you're subtracting is h. Value outside that is k. So when you have a -2 in here, your vertex is at +2. When you have a +3 in here, your vertex is really at -3. That's what having that minus on the inside with h does. So we're at -3, -9. And our value for a is -7. So that negative is going to flip our parabola upside down and make our vertex a max. So our maxed y value is -9. And our axis of symmetry is always x equals the x value of our vertex. So x equals -3 for this one. If we look at the next one, we are not in standard form, or we are not in vertex form, we're in standard form. So we're going to use our vertex formula. The vertex, when we're in standard form like this, is -b over 2a. So in this case, we have a x squared plus bx plus c. So we're going to plug in -b. So our b value is 20 over 2 times a is 5. So we have -20 divided by 10. The x value of the vertex is -2. The y value of the vertex is going to be found by plugging in that -2 to the original function. So I'm going to do 5, and then I'll have parentheses -2 squared plus 20, parentheses -2, minus 6. So I'm plugging into that original function. 5 times -2 squared plus 20 times -2 minus 6. The y value of the vertex is -26. So more work if we're not already in vertex form. We're in standard form. Our vertex is -2, -26. The value for a is +5, so we have a parabola that's opening up. So our vertex is going to be down at the min value. Our min value is -26. And our axis of symmetry is going to be x equals the x value of the vertex. So x equals -2 for this one. If we want to take this a step further and find the domain and range of these, they all have a domain from -infinity to +infinity. If we think about the range of this one, here's the lowest y value is our min. So the lowest y value is 5, and we go up to infinity. If we look at the next one, the domain is always all real numbers, so -infinity to +infinity. Our range down to up, this one goes down to -infinity, and our vertex is the max. Since it flipped upside down, the max y value is -9. And then this last one, our domain is always all real numbers. Thinking about the range for this graph, this is the lowest, down we go, is -26 from our vertex, the y value of our vertex, all the way up, keeps going up forever to +infinity. So there's our vertex, our max and min values, the axis of symmetry, as well as the domain and range for 3 quadratic functions, 2 in vertex form, and 1 in standard form, ax squared plus bx plus c.